we replaced v by cosine when we differentiated. And here we replaced v by sine when we differentiated, correct? And then
Yes.
times the inner function prime. Now this is exactly what we're doing now. We're replacing t by x, but now we're replacing t by x squared. So the first is negative e to x to the fourth, but the next one is n times 1, but the next one is e to x squared.
Yeah, I just noticed that too. All right, now I get it.
I already performed the calculation in my head and I forgot. I'm sorry.
Yeah, I think.
No excuse, no excuse. Thank you, thank you. I wasn't trying to see whether you were asleep or not. No, yes, of course. I said 8 in my head, but I wrote 2 here, so I can't write 8 there. So, of course. So it's x squared, everything to the fourth, copy the base, multiply the exponents. My apologies. Sorry. Sorry. Good. Anything else from 5.3? So thank you, Sean. Instead of telling me, hey, you have a mistake there, you said, please explain. Thank you. I got it. And I had nothing to explain except to apologize. Thank you. Anything else from 5.3? See, in number 3, it gives you the hint. See the hint? Still in 5.3 if you want to look back for a moment. See the hint?
Yes, I see it.
Good. Because we just discussed it, so. Why don't we work on problem 1? Because I don't think there is anything else in 5.3 unless you find something else from 5.3.
Problem 1 in 5.4, you mean?
We're still looking at 5.3, but we can move to 5.4.
Oh, no, I thought you said look at problem 1 in 5.4. But...
I'm sorry, I meant 5.3. I'm
no,
still there.
okay.
I didn't finish. So, or you say no, let's move on to something else. Is it a go for number 1?
Let's do it.
Okay, so I'm going to copy my graph. So this is what I see. So 2 2s, so this is 4. Let me use a different color. And then it goes, so this is 2, this is 4, this is 6, yes, 8, 10, 12, 14. Okay, so 4, 6, 8, and it goes at 4, goes here, and then down to 6. You may have the same graph, I hope. 2 and 4, and it goes to 10, and then 10 to 12, and then to 14. So this is my graph, and of course I'll post this. You may have, as I said, the same graph. And this is function f. And they're asking us to, and they're giving us also g of x, which is the integral from 0 to x from f of t dt. And this is a function in a form of an integral. And they're asking us to find g of 0. So g of 0 is the integral from 0 to 0 from f of t dt. Of course, this is t, and this is y, or g of t. I meant f of t, of course. Sorry, f of t. Okay, so I should have written y. It's the same thing. Okay, so what is this answer? And then we move on to g of 2. What is the integral from 0 to 0 from f of x dx from any function dt?
0.
Yes. So now g of 2. G of 2 will be this. The integral from 0 to 2 from f of t dt. So what will that be? 2 times 4.
8.
Exactly. The next one, g of 4. The integral from 0 to 4 from f of t dt. And that will be this. But I don't want to calculate this again. I want to calculate this. But this is a trapezoid with a big base of 8, height of 2, small base of 4. So here's the trapezoid. This is 2, this is 8, and this is 4. So I want to determine this area. Base plus base times height divided by 2. So the area of the trapezoid is big base plus small base multiplied by the height, everything divided by 2. So 8 plus 4 in our case is 12 multiplied by the height, which is 2, and divided by 2 from the formula. So this is plus 12, so this must be 20. Then I see g of 6. The integral from 0 to 6 from f of t dt. But I already have the integral from 0 to 4. I know it. 0 to 4 is 20. So all I have to do is add the integral from 4 to 6 from f of t dt, which is this area. Base times height divided by 2. It's a right triangle. Base is 2, height is 8, divided by 2. So this piece will be 2 times height, which is 8, divided by 2. So this is 8. So this is 20 plus 8, which is 28. Last one I see is g of 12. Any questions so far? Any questions?
No questions.
Is this okay, everyone?
Yes.
Okay, so now we have g of 12. Okay, what is g of 12? Careful now. This was all what type of area?
Positive.
This is all what type of area?
Negative.
Good. So I want to determine this area, and I have to subtract it from that. Base, big base, small base, and height of 4. So g of 12 will be 28 minus base plus base. So this is 2. So 6 plus 2 multiplied by the height, which is 4, and divided by 2. So I have 28 minus 8 times 2, which is 16. So the answer is 12. I think something else follows. On what interval is g increasing? Very good. So this is part B. This was part A. And this is part B. So g is increasing on what interval? Can anyone tell us on the interval on which g is increasing?
I'm not sure what your graph looks like, but from 4 to 6.
So from 4 to 6, see, I started with 0. I'm adding areas, I'm adding area, I'm adding area, I'm adding area. So the function is increasing between
0 and 6.
exactly. And where it starts decreasing then. So I will say G increasing, and remember these intervals have to be open intervals, 0 to 6. Now there is part C. Where does G have a maximum value? Part C. Max value of G of X is, where does it have a maximum value? And we have it. We determined it. Where does it have a maximum value? $137. This is the previous lecture that I have to upload. Okay, where does it have a maximum? It's exactly where we started subtracting. That's where it has an absolute maximum value. Right before we started subtracting. So the maximum value is when X is
6.
excellent. When X is 6. Exactly. Perfect. Sketch a rough graph of G. Okay, very good. We have points. So let's sketch a rough graph of G. So 2, 4, 6, 8, 10, 12. This is X now. And this is G of X. Okay, so let's see what points I have. When X is 0, the function value is 0. When X is 2, the function value is 8. And since I'm getting to 28, I'm going to use a smaller unit, like 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Okay. And then 2, 4, 6, 8. Okay, so at 2 is 8. At 4 is 20. At 6 is 28. And what else we have? We have that at 12. At 12 is 12. Okay. It's a rough, as they say. Complete rough. I had plenty of points to create the graph. A rough estimate, of course. Okay, perfect. Do you think we can move on from this section? Do we have everything we need for this first section? Is that a yes?
Yeah, I think so.
Okay. Let's jump to the substitution rule or any other you choose. I don't want to choose. You choose. Which section? Which section are we working on now?
So the previous section was
5.3.
3, right?
Yes,
Yeah.
and I think we exhausted it. I think we went through each and every type. So you can finish that even tonight. I don't want you to rush through it. I want you to think, but you can finish everything in half an hour from that section. Next. We want to go to which section?
We could do 5.4.
Which one? 5.4?
4.
Very good. Let's move on to 5.4. Let's see what catches our eye in 5.4. There are 18 questions. Anything catches your eye?
Maybe something like 13.
Very good. 13. The integral from 1 through 64. 3 plus the cube root of x over the square root of x dx. Very good. Well, what do you think I'm going to do here? Because the denominator is just one term. When the denominator is one term, I will definitely split it up. Split up the fraction into this over this, and this over this. It's not a friendly problem. I'm glad you chose that. It's not a friendly problem because of these powers, right? So this will be 3 over x to 1/2, and I have to rearrange that. So the integral from 1 to 64, 3 times x to negative 1/2. And this one is even uglier because the power of the top is 1/3 and the power of the denominator is 1/2. And remember, we have to find the least common denominator, which is 6. This numerator needs to be multiplied by 2. This one by 3. So 2 minus 3 will be negative 1. So then plus x to negative 1/6 dx. And now it's ready. So it's 3. Remember, x, we increase the power by 1 when we divide by that number. Plus x, we increase the power by 1 and we divide by exactly that number. And now from 1 through 64. It's ugly, but I have to clean it up before I plug in these numbers. So negative 1/2 plus 1 is 2, and I have to, it's 1/2, so I have to flip. So this is 6, and x to 1/2. Negative 1/6 plus 1 is 5/6, so I have to flip. Plus 6 over 5 times x to 5 over 6. 1 through 64. Okay. So when I plug in 64, this is the square root of 64, which is 8. So it's 6 times 8 plus. This is also nice because it will be the 6th root of 64, which is 2. 2 to the 5th, 32. So 6 over 5 times 32. So let me show on a side note here how I did that. So we have x to 5 over 6. And I replace x by 64 to 5 over 6. But 64 is 2 to the 6th power. And these will simplify, so that's how I got 2 to the 5th, which is 32. Or you can plug it in the calculator. That was a side note. Okay, now I have to subtract when I plug in 1. But luckily these are gone when I plug in 1. So I have minus 6, don't forget to distribute, minus 6 over 5. Okay. So now I want to factor out this 6 because it bothers me. So this is 8 plus 32 over 5 minus 1 over 5. I took out this from all of them to simplify my calculations. So 8 minus 1 is 7. 32 over 5 minus 1 over 5 is 31 over 5. I'll put it back in, but not just yet. 6, 7 minus 30, positive 31 over 5. So this is 6, and this will be 5. So this is 35 plus 31 over 5, which is 6 multiplied by, what is this? 66. Is it? Yes. Over 5. Or if I multiply 6 times 6, 36, 39 over 5. Good pick.